In this section, we're going to practice factoring polynomials. It'll help us to remember what a polynomial is and what factoring means. Remember first that a polynomial has multiple terms added together. So an example of a polynomial would be x squared plus 2x plus 3. We have multiple different terms added together. Remember, factoring asks the question, what two things can I multiply together to get a particular number or expression? So in earlier grades, when you factored, you took a number like 63 and asked, what other numbers can I multiply together to get this? So factoring polynomials asks the question, what things can I multiply together to get a particular polynomial as a result? First, we're going to look at cases where all we have to do is to factor out a monomial. That means to factor out one term. So an example of a problem where we'll factor out a monomial looks like this. 3x squared plus 9x equals. And we're trying to break it into two things that when we multiply them together will result in this expression, 3x squared plus 9x. We're going to use the area model of multiplication that we've been working with because we remember that this model helps us think about multiplication as the length times the width of a rectangle gives us the area. In this case, we actually know the area that we're aiming for. It's 3x squared and positive 9x. And the question is, what do the length and width of this rectangle have to be? The length and width will be the factors that give us a rectangle of this area. So in this case, I'm going to focus on this side first. I'm going to look at these two terms, 3x squared and plus 9x, and ask, do they have any factors in common? Well, I notice that x is a factor in both terms, so I can put an x out here. I also notice that 3 is going to be a factor of both terms. In this case, I can see that there's already a 3, that's one factor of 3x squared. And in this term, I know in my mind that 3 is a factor of 9. So I know that 3 is going to be a factor of both terms. So now I'm asking myself, 3x times what gives me 3x squared? Well, it must be 3x times x to give me 3x squared. Then I'll ask myself, 3x times what gives me positive 9x? That case is positive 3. So I think that I have the factors, the length and width of a rectangle that has an area of 3x squared plus 9x. I think those two factors are 3x and x plus 3. Let me check this using the distributive property. 3x times x plus 3. If I multiply this using the distributive property, 3x times x gives me 3x squared. 3x times positive 3 gives me 9x. It does indeed check. The next thing that we're going to look at, and we'll do this a lot, is factoring a trinomial. Remember that prefix tri means 3. So this is going to be an expression that has 3 terms added together. Here's an example of a trinomial that we might be asked to factor. X squared plus 5x plus 6. It has 3 terms, a squared term, a plain old x term, and a constant term. We're going to factor expressions that look like this a lot. And to remind ourselves what factoring in this case means is that we're looking for 2 expressions that when we multiply them together will give us this. So let's set up our area model and see what we can fill in and what we need to figure out. We know that we're going to have part of our area model that has an area of x squared. I'll write that in here. And we know that part of our area model is going to have an area of positive 6. I'll write that in here. And then we know these 2 rectangles in our area model have to have an area that adds up to 5x. So let's see what we can do with just the information that's in our area model so far. I know that the length of this side section here has to be x, and this side section has to be x, so that when x times x gives me x squared, I get this chunk of my area model. And I know that the number here and here, when I multiply those two numbers, the answer has to be 6. So I'm going to guess some factors of 6 to go here. I'm going to try 3 and 2. We're going to do a lot of guessing and checking in this unit, and if we happen to guess wrong the first time, that's just something we can learn from. So let's see if 3 and 2 give us the correct numbers for these two remaining rectangles that add up to positive 5. 3 times x is 3x, and x times 2 is 2x. Now in my area model, when I add these four terms together, x squared plus 3x plus 2x plus 6, and then I combine like terms in the middle, 3x plus 2x, that is indeed positive 5x. So it looks like by putting 3 and 2 along the sides of my area model, I did in fact get the right factorization for this polynomial. So it looks like the factors of x squared plus 5x plus 6 are x plus 3, that's across the top, and x plus 2, that's down the side. Let's use FOIL to check and see if we got this right. So let's multiply out the first terms here. X and x gives us x squared. Then let's multiply the outer terms, x and 2 gives us positive 2x. Let's multiply the inner terms, x and 3 gives us positive 3x. And let's multiply the last terms. 3 times 2 gives us positive 6. We'll combine the OI in FOIL, and we'll have x squared plus 5x plus 6. That is indeed what we were aiming for when we started our factoring. So our factorization is correct. Next, we're going to try factoring another trinomial. This one is x squared plus 9x plus 8. And in this case, I'm going to show you what happens if we guess wrong when we're looking at factors of 8. So let's go ahead and set up our area model. So I know that we have x squared is the first part here, and positive 8 is the other part of our model here. So what I need to do is I know that I have x and x along the sides of my area model here. X times x is x squared. And what goes here and here, those numbers, when I multiply them together, need to give me positive 8. So I'm going to guess that the factors that go in these two blank spots here are positive 4 and positive 2. So let me now multiply and fill in the rest of my area model. 4 times x is 4x, and x times 2 is 2x. Let me add these four terms together. X squared plus 4x plus 2x plus 8. I'll combine my like terms in the middle. That gives me 6x. So I have x squared plus 6x plus 8. This is a problem because I wanted my middle term to be 9x. So when I multiply x plus 4 and x plus 2 together, I don't get the right trinomial that I was aiming for. It looks like when I guessed 4 and 2 as factors of 8, that factor combination didn't work. So I need to try again. I still need for the area of this square to be x squared. I need for the area of this rectangle down here to be positive 8. So I know that I need x times x to give me x squared. Now I'm going to think about the factors of 8. I tried the combination 4 times 2, and that didn't work. So the only other factors I can think of are 8 times 1. So let me try that. Let me try positive 8 and positive 1 as factors. 8 times 1 is 8, so that makes this little bottom rectangle work out okay. 8 times x gives me 8x. X times 1 gives me 1x. Now let me add all of these terms in my area model together. I'll get x squared plus 8x plus 1x plus 8. And I'll combine my like terms. So I have x squared plus, 8x plus 1x. That gives me 9x plus 8. That does indeed give me the trinomial that I was originally trying to factor. So the factors of x squared plus 9x plus 8 are, across the top, x plus 8, and down the side, x plus 1. Next, we're going to practice factoring a trinomial that has some negative terms. So here's a trinomial, x squared plus x minus 6. In this case, I think it might be helpful if we write in the missing coefficient on this middle term. So we remind ourselves that this polynomial is also written as x squared plus 1x minus 6. Now, let's make our area model and start filling in factors. So we know that part of our expression is going to need to be x squared. So I know right away that I'll need an x and an x along the length and width of my rectangle. And I know that part of our expression is going to need to be negative 6. So I know that the numbers that go here and the numbers that go here are going to need to multiply together to give me negative 6. I'm thinking that one of them will need to be positive and one of them will need to be negative. Rather than guessing and throwing factors of 6 in right away, let me stop and think for a minute so I can be strategic about what factors of negative 6 I choose. Let me list out some of the factor pairs of negative 6. Negative 6 is equal to negative 3 times 2. It's also equal to 3 times negative 2. It's also equal to 6 times negative 1. It's also equal to 1 times negative 6. And so as I look at these factor pairs, I'm going to think to myself, which factor pair looks likely to add up to this positive 1x that I'm going for? And what I notice is that this factor pair here, 3 and negative 2, 3 and negative 2 add up to positive 1. So I'm going to try 3, positive 3 that is, and negative 2 as the factors of negative 6. Let's see how this worked. 3 times x gives me 3x. X times negative 2 gives me negative 2x. When I add up all of the squares in my area model here, I have x squared plus 3x minus 2x minus 6. When I combine the like terms in the middle here, positive 3x and negative 2x, that adds up to positive 1x. So I have x squared plus 1x minus 6. This is indeed the original trinomial that I was aiming for. So the factors of x squared plus 1x minus 6 are x plus 3 and x minus 2. We can check this using FOIL to make sure that we got it right. Now, I want you to do some practice on this. On this first practice problem, I'll give you a little bit of help setting it up. The trinomial we're going to factor is x squared plus 6x plus 9. And again, remember, I'm trying to figure out what two expressions do I multiply together so that this is their product. Let's set up our area model. I know that this square needs to have an area of x squared for the first term. And I know that this bottom rectangle down here needs to have an area of 9 for my last term. Your challenge is to figure out what numbers go here and here, and then here and here, such that when you do all of your multiplication, these two rectangles have an area that adds up to 6x. Please pause this presentation while you work through this. We'll go through the answer together in class. And two more practice problems for you to do. X squared minus 4x plus 3. Please do draw out your area model for this. And x squared minus 3x minus 4. Again, please do draw out your area model for this. We'll go through these together in class.